Welcome to this demonstration of AI-assisted development for Oniro and OpenHarmony applications using Visual Studio Code. Today we'll explore how artificial intelligence can streamline and accelerate the development process for OpenHarmony apps from initial setup to building a complete application. Before we begin, let's review what we need for this demonstration. We're working with a Linux development machine that has Visual Studio Code installed along with the Oniro IDE extension. We also have the OpenHarmony SDK and command line tools properly installed. If you need detailed guidance on the setup process, please refer to our previous tutorial, which covers these installation steps comprehensively. Our first step is to download the app Oniro template by cloning the Git repository. This template provides us with a solid foundation, essentially a Hello World project that serves as our starting point for OpenHarmony application development. Now, let's open this project in Visual Studio Code to begin our development journey. With our project loaded, assuming we have the Oniro IDE extension installed, open the Oniro Tools view in the activity bar. Let's click on Sign to generate the necessary signing configs for our application. Now let's test our setup by building the application. We'll click on Build, and as expected, this should succeed with our basic template. Here's where things get interesting. Let's see if our AI agent can successfully run commands to build the application. As we can see, the build has failed because the SDK path is not properly configured. Following the system's suggestion, we need to create a local .properties file in the root of our project. Inside this file, we'll insert sdk.dir equals followed by the path to our SDK installation. If you used the Oniro IDE SDK Manager as demonstrated in our previous tutorial, you'll find this path in the Setup OHOS SDK directory within your home directory. With this configuration in place, our AI agent should now be able to build the project successfully and check for any errors that might arise. Now comes the exciting part. Let's ask our AI agent to create an entire application from scratch. We're going to request a notes application with simple input functionality and storage capabilities to type and save simple notes. Notice that we're providing the AI agent with a reference to documentation about TypeScript to ArcTS migration. This is important because AI-generated code often uses TypeScript syntax and constructs that aren't fully compatible with ArcTS, OpenHarmony's development language. We're also giving it the specific build command and instructions on how to check for errors. The AI model we are using is Claude Sonnet 4. Let's watch as the AI agent generates the code for our notes application. The AI agent is now working on our request. When it asks for permission to run commands, we'll allow it to proceed. You can see how the agent iteratively builds the project, checks for errors, and automatically fixes any issues it encounters. This iterative approach is one of the key advantages of AI-assisted development. It can quickly identify and resolve common coding issues without manual intervention. Excellent. The AI agent has completed the code generation process. Our notes application is now ready for testing. Let's open the Oniro Tools view and click Run All to build and run our application on the Oniro emulator. Perfect. Our application is now running. Let's put it through its paces by creating some practical examples. We'll create a new note for a shopping list, and another one for a to-do list. As you can see, the application handles note creation smoothly. Now let's test the deletion functionality by removing these notes. Excellent, everything works as expected. This demonstration showcases the power of AI-assisted development for Oniro and OpenHarmony applications. In just a few minutes, we've gone from a basic template to a fully functional notes application, complete with input handling and storage capabilities. The AI agent not only generated the code, but also handled the build process, identified errors, and fixed them automatically. Thank you for watching this demonstration.